Alright guys, happy Chinese New Year, and today I'm going to talk about question 10 on LeetCode. So we're given a input string S and a pattern P, and we're trying to implement a regular expression matching that supports dot and star, where the dot can match any single character and star can match 0 or more of the preceding element. So for example, if we have a as our S, and our pattern can be A star, and this way this is a correct match. And also we're given that it's guaranteed that for each appearance of character star there will be a previous valid character to match, and so we can assume that our input is always valid. Okay, so there's a few situations that we need to talk about. So if for example, if we have S as A, B, C, D, E, and here we have let's just say this is S and P. We have A star, and then like B star, let's see, like a Z star, and then B, C, D, E. Okay, so first, and okay, so maybe we can change this out to like a dot. Okay, so if two elements are the same, we know that this is a valid position, and that's obvious. And or if we encountered a P that is a star, that means we can there's two options. So either we can inherit, we can repeat the previous character to try to match the current character, or we can don't use this character at all. So so in this case, we can either let this star to be another A or multiple A's, or we can just ignore it. So we can take it as either this or blank. So in our particular case, we actually want it to be blank. So if we want it to be blank, we know that at this position, it is valid as well. All right, next step. So if we're looking at Z, and if we're looking at Z, and it doesn't match the current character, and so we know that this is a so we know that it's not going to work. And we'll go to the next character, which is another star. So there's, like I said, there's two possible ways, right? So we can either repeat the previous character, we can have multiple Z's, or we can have just empty. And how do we know if we want to inherit? We need to compare the previous character with our current character. If they're the same, we can mark this position as check. But because the previous position is across, so we know that this is not going to work either. Okay, so I'll continue. Now, if let's say if we're looking at this B, and there's a couple ways. So if we compare B and B, okay, so they match right away. So okay, that's good. And we can continue to this dot and this C. Okay, so the dot can match anything, right? So we can just say that we're good. And and everything else is good. So we know that finally, if we're end of both arrays, we know that we can return the return true, otherwise we need to return false. So like I said here, I kind of skipped something, which is on each step we kind of just compare this b with this b, but in reality we will compare this b to every other element inside S, and obviously all these precision will be it's not going to work. So yeah, and so if for space and time complexity, if S is m and p is n, the space, the time will be O of mn. And space-wise, because we're using kind of like a matrix here, and that is m by n, so the space is also O of m by n. Okay, and there's one pre-processing that we need to do, that is when when basically S is empty. So if S is an empty string, and we want to know if P, the value in P can matches that, the only way that P can match this empty string is if P itself is empty, or we have like A star and B star, C star, like this, or like a dot star. So whatever is, so the only way is if the star is, there's a letter before every start. So every letter is followed by a start. That way we can match a empty string. So we need to check. We need to go through the entire P array, and if we're at a dot, at a star, we need to look at the previous element. If that is the element, we know that we can take it away and just throw it away. And we need to, if we see a star and we check the previous element, and if it's just an element, we know that we can throw it away. And so if this happens, and we know that we can throw this away and we can throw this away, but there's still A left behind, and this A will be, so this location, so we'll have a matrix of like this, right? This is empty, and this is A star, A, B star. So at this position, we know that we're good because this block we can throw it away. And at this block, we don't know yet. And at this block, we know for sure that we don't know yet, so we put it as can't. We cannot do it. And at this block, we know that the B obviously doesn't match empty, so we know that we can't do it either. And finally, we'll look at this star, so we'll look at the previous block position, so, and this block. And because we cannot throw away this A, so we will inherit this X, so we'll put an X here. Which is, finally we'll just look at this position, and we know that we need to return false. Okay, let me code this up. So let me delete all of these. Yeah, so here's a question description. So first we'll need to create a dynamic programming 2D array to 2D Boolean matrix to store the result. So let's get a dimension first. So m will be s dot length, and n will be p dot length. Okay, and here let's do the 2D DP array, DP matrix. M plus 1, m plus 1. So the reason here we're using m and n plus 1 is because we're working with strings, and the strings can be empty. So okay, so first of all is some pre-processing. We know that dp00 is when both arrays are empty is true, and also for int I equal to 1, I less or equal to m, I less. This is a case where s is empty, and we try to see if we can match p to it. So if p dot here it is, and p dot char at I minus 1 is equal to star, and our current position, which is dp0 I, will inherit dp0 I minus 2, because if I minus 2 can make it, is something, for example, if we're at the star, and if the previous location we can throw a star, that means our current position we can have it as true as well. Okay, so that's some pre-processing, and then we can just start populating the DP matrix. So I is equal to 1, I is less than equal to m, I plus plus, j is less or equal to n, j plus plus. Okay, so let me get the characters that we're looking at. Cache that, so we don't need to accessing the string for that every time. So 1 is equal to s star char at I minus 1, and char 2 is equal to p dot char at I minus 1. We're doing I minus 1 here is because I can go to m, and if we do char at I, we'll have index out of bound. Okay. And now let's just look at if 1 equal to 2 or 2 is equal to the dot. We know that this is a case where 2 letters are the same, like this B and B, or this dot or any other letter. So we know that in this case dpi j can inherit whatever is before. So whatever, so in this case, we know this can work, but we also, and the dp at this position is inherit from here. So whether we can make the star and a work, which is, I think, I don't know, but this is the idea. I minus 1. J minus 1, we need to inherit from the previous location. Otherwise, there's 2 cases that we need to consider as well. So if our 2 is equal to a star, there are 2 cases here. So one is if my previous location, which is this is easier. So if we're at a star, there are 2 cases. So if we can inherit from the previous, so if the previous, if the char before the one we want to, okay, so there are 2 cases. The first is we can either repeat the previous one, or we can not repeat it. So if we look at dp I j minus 2, that is true, means that we don't repeat the current character. we can just have dpij equal to true. Otherwise, if my dp p dot char at I minus 2, which is the letter before star, is equal to my my current character, meaning repeated character, or the previous character itself is equal to the dot. That means we can inherit whatever is. So meaning we are repeating the correct character, right? So meaning that if you want to determine whether we can inherit the previous character, we need to look at this position. So if at previous location we are repeating the character, and at this current position we're repeating it again. So dp I j is equal to dp. This is actually not I minus 2, it's j minus 2. And this is j minus 2 as well. And dp I doesn't move, but it's like this. So if at dp I minus 1j works, we know that we can safely repeat the current character, because this is true, so we can just inherit that value. And at the end of the day, we can just return dp mn. Okay, let's test this. Okay, that looks good. Submit. All right, thank you.